complete at Neon EVM, and today we'll see how we can scale our Ethereum dApps with Neon EVM. So let's first talk about what is Neon EVM, because I've had a lot of questions. Is that the next layer 2, and actually what it is about? So in a nutshell, no, Neon is not a layer 2, is not the next and not the next layer 2 solution. It's something different. So actually Neon EVM is a smart contract in Solana, and this nothing more from the smart contract in Solana. We have a lot of other services, but why is that? And actually, the first thing is that Neon EVM combines both the best worlds. Basically, we all know that Solana is actually famous with its scalability and really cheap transaction costs and low gas fees. So on the one hand, we combine Solana benefits that we can have parallel execution, low gas transaction fees. We have access to Solana ecosystem, and also we have access to Solana liquidity natively in our dApps. And we all know that Ethereum ecosystem and Ethereum tooling is widely used and one of the most used out there. So we are fully compatible with Ethereum, with Solidity, Viper, and all the Ethereum tools out there like MetaMask, Hardhat, Truffle, and we have a fully compatible Ethereum RPC. So how do we achieve those? So, because only having the Neon EVM as a smart contract, you can't really achieve compatibility with MetaMask, with Hardhat, because let's imagine Neon EVM was only a smart contract in Solana, so you need still to use Phantom Wallet, right? And Neon EVM is actually a whole set of products and a whole set of services that actually represents the Neon EVM. And the smart contract, Neon EVM, is only the first service. We have the proxy server, and this is one of the most important services, I might say, that we can bring Ethereum-like EVM compatibility and user experience. So the proxy server is actually the public RPC that all users and developers interact with our blockchain. So it's having a complete Ethereum-like RPC, and it's actually bridging the gap and abstracting away how to build Solana transactions, and you can just build your own Ethereum transaction, and the proxy understands of how to unpack this Solana transaction and wrap it into this Ethereum transaction and wrap it into a like Solana transaction. We'll have example about the exact architecture of the proxy. So we have also the Tracer API. The Tracer API actually allows users to query Neon EVM and actually get a structured data. It's compliant with EIP 1898, and it's the same like as you can query any blockchain for any historical data. We have Neon Path, which is our native bridge from Solana to Neon EVM. Neon Faucet, which is our DevNet faucet that you can mint your own testnet tokens and basically test our system. And we have Neon DAO, which is currently under development, but very soon Neon DAO will be the owner of Neon EVM, and all the changes in Neon EVM will be governed through governance. And last but not least, as you can see, we open a lot of use cases for developers, and you can see how much is one transaction and how scalable we are, and that's because of we use Solana as underlying architecture, and we will see how we managed to do that in a second. So, yeah. So in terms of infrastructure and ecosystem, We support different types of infrastructures, dApps, so we support safe wallets, we support PIS network, we also support data indexers like the Graph and Covalent. Moreover, not only PIS, but because Neon EVM is a smart contract in Solana and we have some interoperability in place, we can natively read chain-link price feeds from Solana. And basically, we bring that on the table as well. In terms of dApps, we launched a mainnet a month and a half ago. So we have around 5 dApps. And also we support those wallets. We support Ledger from the embedded app, and soon we will support Ledger Live. In terms of dev tooling, basically we support all dev tooling for Ethereum developers. As you can see, even the most famous right now through Foundry, which is very, very famous and trending in smart contract development, and also security researchers. We support OpenZeppelin, Ether.js, Web3.js, basically any product for dev tooling out there is supported by us. So yeah, let's go one step deeper and see how Neon EVM works, and actually how do we manage to provide this compatibility. So let's say we have a dApp, and this dApp is like an EVM dApp, right? So here is our Neon EVM. This is Solana. Our Neon EVM is like a program in Solana. So Neon EVM understands of EVM bytecode, can execute EVM bytecode inside the Solana virtual machine. So Neon EVM is like a translator for EVM dApps to execute their logic and their EVM bytecode inside the Solana virtual machine called the BPF, Berkeley Packet Filter, right? So we have the front-end app, which submits Ethereum-like transaction to our public RPC, and this is our proxy. And basically, the proxy on the one side provides a fully compatible Ethereum-like interface, and it unwraps the Ethereum-like transactions, creates a Solana transaction, and calls Neon EVM program with the EVM bytecode and with the instructions that we want to have. Rather, if it's deploying new contracts or transferring funds or anything any operation that we can do in normal EVM, we can do with Neon EVM. Why is that? Let's have a look how Solana works, because I mentioned that Solana is very, very scalable, but this is because they have chosen a very, very different approach on their architecture. And one of the main reasons Solana is very, very scalable is because it is stateless, and because it has parallel execution. So why it is stateless? It's stateless because programs in Solana, this is one Solana program, they don't have state. We have two kinds of accounts in Solana. We have a program account, a Solana program, and you can see we have executable flag inside them. So, and we have data accounts. So you can imagine a Solana as one big file system, right? We have two types of files. We have executable and we have data files, right? So in order to represent the state inside the Solana program itself creates data accounts to store the state. Like Solana program creates files that it can later read from them and recreate its state. So yeah, this is in And also, of course, the owner of those accounts is the Solana program by itself. So this is in a nutshell how a classical Solana program looks like, and let's have a look how Neon EVM looks like. Because as I mentioned to you, Neon EVM is actually a smart contract. So it's a Solana program that basically can execute. So this Solana program understands EVM bytecodes, and it can create new accounts. It can deploy new contracts, and the contracts by themselves maintain their state by deploying new data accounts. So, in a nutshell, all transactions that are initiated to Neon EVM, they are with an entry point, Neon EVM, and after that, you can see that we have different paths. If it's deploying a new contract, creating a new executable, let's say, file in the Solana context, you can see that we also have the Neon account, and here in this account, it's like the same data, it's like the same like data address, but inside the data we store the address, the nodes, the balance, like all the metadata that is connected to this Ethereum account. So how do we build, this is how a Solana transaction works. So after the proxy receives the Ethereum-like transaction, it needs to unwrap this transaction and actually create this Solana transaction and submits it. So one of the most important things is actually the account list. We don't have this in an Ethereum transaction, and this is actually which accounts are going to be modified in this transaction, and this is done because to enable parallel execution. So in theory, you can do parallel execution on Neon EVM if you're not going to have the same account list for two transactions. So in theory, you can be very, very scalable, and this also opens a new, I would say, a new architecture for builders and give them more space for creativity on how to use Neon EVM. And as you can see, we have program index, which is the index of Neon EVM, and also we have some data, and inside this data we have nodes, gas price, all the Ethereum metadata. And you can see this is actually a graphic after we have the Neon proxy. After the Neon proxy submits the transaction to the Solana RPC endpoint, we have the Neon EVM program, which is always the entry point. So if we have two transactions with different, I would say, account lists that are going to modify different accounts, both transactions can be executed at once on the Neon EVM. It's a little bit hard to grasp, I know, because parallel execution is not really, is a very, I would say, foreign term in EVM, and we all know EVM is single-threaded. So, yeah, we had a lot of hurdles in order to make this work, because Solana is very scalable, but sometimes Solana has some restrictions on single transactions. So in Ethereum, the only limit that we have to create a transaction is the block gas limit, which is 3 million, right? So as long as you don't reach the block gas limit, you're fine, and as long as you pay your transaction fees. So how we did that is we have this iterative execution. So if a transaction is really, really big, we split this Neon EVM transactions into a couple, maybe 10, 20 Solana transactions. And as you can see, this is Neon proxy. It submits, it actually recreates the iterative transactions and submits the transactions one at a time. So as you can see, initially the first transaction blocks all the accounts because we don't really want to have any racing conditions or any other transaction to come and basically read a false state or write to a false state. So always the first transaction blocks all the accounts, and also the last transaction saves state of all the accounts, and actually the last transaction actually sends the receipt, the proxy sends the Ethereum transaction receipt to the user. So all those transactions, as you can see, they are iterative, but from the user perspective, this is one big transaction. And inside our blockchain explorers, you can see that you have the Neon transaction and you have the underlying Solana transactions, and you can click and see the exact trace of the Solana execution. And again, when we are talking about parallel execution and iterative transaction, the other question that comes to everyone's mind is how do we ensure atomicity, right? And I actually said it in the previous slide. We always block accounts, and we write the state and unblock accounts in our last. This is if the transaction is too big, if it's more than one transaction, we will always perform those 3 steps, right? So if another transaction tries to execute parallelly, it will revert because all the all the accounts, or even one account is blocked, it will be reverted, right? So the transaction will be actually reverted and rejected. So what's next? Yeah, so we will try to, because right now everyone knows that we're not layer 2, we're maybe layer 1.5, I don't know, you can call it however you want to, but we are a smart contract in Solana. So we can bring interoperability in Solana natively in our dApps. We started with bringing ERC, Solana SPL tokens natively into Neon EVM. So all builders, all dApps can use Solana liquidity right now in their dApps. They can wrap an ERC20 token that represents an SPL token in Solana, and they can actually use those tokens in pools, in their protocols, and so on. So our next step is bringing Solana NFTs, but our main goal is to bring a general interoperability into Neon EVM. So developers to be able to use any application or any new feature that Solana brings on the table to be used natively in Neon EVM. So yeah, that's pretty much it. I hope you understood what Neon EVM is, and yeah, if you have any questions, I'll be more than happy to answer. Thank you.
Does your EVM support batch of transactions?
You mean batching? Yeah. I think currently we don't support batching of transactions, but on a network level, but on smart contract level, we support it. I mean, you can have a multi-call contract deployed, and you can just submit a batch transaction like that. So we support it. We have been restricted a little bit from Solana because you can't really modify more than 64 accounts. So so you can't really submit a really big batch transaction, but you can submit definitely batch transactions. So yeah. Thank you very much, guys.